No, okay, so we're going to make a definition here. And I forget the number of this definition at this exact moment. Let's number what? 3.11. Awesome. 3.11. So this is what we're going to call colon notation. For those of you that are in engineering 11, you're going to laugh at me right now, like, oh, come on, this is trivial. A useful way to refer to individual columns and rows. So this one is yours. And those are yours. A useful way to refer to individual columns or rows of a matrix is using the colon. So this is, I think, is that, would you call that English grammar? Is that symbol from the field of English grammar, or is it from the field of? Grammar. It's grammar, right? Thank you for that. I felt like the silence made me feel stupid, but you just made me feel really good. Yeah, okay, that comes from grammar, and in this case we're going to abuse that thing. And I had a really good question about this. So if I write A parentheses, double dot, or the colon, and then K, this is going to be what we call the name of the matrix. So what's the matrix name in this case? A. The parentheses are going to be used to address the matrix. Right? So inside these parentheses, there's going to be a matrix address. When we see a colon, think take all entries, take all entry indices here. So if it comes first, could you guess which indices you're going to take all of? The rows. Why would you take all of the rows if it comes before the comma? What comes first in matrices? Rows or columns? Rows. So this is literally, go to the matrix A, take all rows in column K. So this is now specify column K. And let me just, column number, I guess. Let me just remind us real quick. I think we did talk about this operator. So this is a recall. Didn't we talk about this operator last time, the entry operator? Yes. Do you remember how we used that address notation in the entry operator? If I wanted to refer to the ikth entry of A using parentheses, how would I do that? Yeah, so this would be A, I, K, and then if I wanted to do subscript notation, what would we do? Lowercase a, I, K. So in this case, we would say that this particular vector.
Jeff, is it just standard notation to have uppercases as a matrix and lowercase?
That is a beautiful question. Yes. In general, unless told otherwise, there are some fields that violate this rule. In general, we use uppercase letters for matrices, and we use lowercase letters for vectors. I don't know if you've noticed that when I write vectors on the board, I'll use a vector hat, but when they're typed, they're bold-faced. That's pretty standard for introductory literature. As you get more deeper into literature in the field, authors won't even use bold-faced or vectors because the implicit invitation to the reader is to do what every single time you see anything in linear algebra? Check the dimensions. So they don't. Why would I waste time doing \math boldface if they're supposed to check the dimensions anyways, right? So there are some young students that will read graduate level textbooks and they're like, oh, I can't tell if this is a matrix, a scalar, or a vector. And then the first thing I'll say is write the dimensions, right? Okay, so here, do you know how big this vector is? In the context of this class, every time we've written A.
M by N. Oh.
M by what?
M by N.
M by 1.
N by 1. Why is it M by 1? Because this thing is actually the kth column. So you actually gave the right answer to a different question, Kitana. You were saying that this k index does relate to the matrix, right? But what does it relate to?
The kth.
The kth column. So this is called the kth column of A, of matrix A. And then let's go ahead and actually write this. If I wrote the kth column of A, what would that actually look like in terms of the individual vector entries? I mean, A, 1k, 2k, yep, all the way down to mk. Why would it be mk? Yeah, because in general we've assumed every time we have a rectangular matrix that it has m rows and n columns.